To develop an iOS app, not only do you need a good understanding of the iOS environment and interface, but you also need good knowledge of Objective-C. Objective-C is the programming language used to develop both Mac and iOS applications. Let's take a closer look at Objective-C. This video will help you explain the basics of Objective-C and declare classes and instantiate objects in Objective-C. Objective-C is a compiled language, which means that it gets compiled down to raw machine code as opposed to being interpreted at runtime. Based on C programming language, it is actually a superset of C that adds object-oriented programming methodologies. Its syntax and concepts are similar to C-based languages. Message passing or method calling is a method in OOP languages in which an object can send a message or call a method of another object. Notice the syntax in Smalltalk, Objective-C, Java, and C# for message passing. Being an object-oriented programming language, Objective-C includes objects, classes, and their method of inheritance. Objective-C enables intelligent coding and helps you add smart features to your apps. The primitive data types in Objective-C are bool, char, short, int, long, float, and double. Other than the primitive data types, Objective-C also allows you to name new data types using typedef. For instance, let's create a data type called myInt using integers. Other than typedef, Objective-C also allows you to create structs. A struct is a compound data type made up of primitive data types and is used to encapsulate similar data. Developers often use typedef to avoid having to use the keyword structs when using them in code. The three common structs in Objective-C are cgPoint, cgSize, and cgRect. This code shows how structs are defined. Let's now look at how to declare classes and instantiate objects in Objective-C. Objects in Objective-C are the building blocks of applications. They have member variables that describe an object and methods that can manipulate public or private member variables and their parameters. Objects are defined in a class. The class acts as the template for how an object is created and behaves. A class in Objective-C consists of a header file and an implementation file. The header file, .h, contains the interface of a class. This is where you declare the member variables and the method signatures. The implementation file, .m, contains the code for various methods. Let's now compare classes in Objective-C with Java and C#. A namespace is a way of grouping related classes together. However, Objective-C does not have the concept of namespaces. In Objective-C, a class is made visible to another class simply by importing the header file in which the class's interface is declared. The public keyword is also used to declare if member variables are visible to other classes. In Objective-C, all methods that are declared in the interface are visible to other classes. If a class needs a private method, it just adds the method to the implementation file. All code within the implementation file can call that method, but it will not be visible to any classes that import the header file. In Objective-C, virtually every class inherits from NSObject. NSObject defines the code for managing the memory of an object in Objective-C. Objective-C method signatures tend to be very long and explicit. For instance, sum with third int, fourth int, method is a method signature. The colons in the method name denote the number of parameters the method takes. By having the parameters listed in line with the method name, you can create signatures that are easier to understand. Let's now look at instantiating objects in Objective-C. An object needs to be instantiated and created in memory. In Objective-C, you can instantiate an object in two steps. 1. The first step uses the static method alloc, which finds enough available memory to hold an object and assign it. 2. The second step uses the init method to set memory. The pointer dereference operator helps dereference the pointer and gets or sets the object in memory. The variable simple class instance, for instance, is a pointer. The value it holds in memory is not the object, but the address of where the object exists in memory. In other words, it points to the object in another part of memory. Here's another example of instantiating objects. In Objective-C, the ID type can hold a pointer to any object. This makes Objective-C a dynamic language, meaning that you do not have to give a specific type to an object at compile time. When you use the ID type, its actual type is determined at runtime. Returning ID from an init method is part of a COCO convention, which is often followed. Another important aspect in Objective-C is the self variable. It refers to the instance of the object that is receiving the message. When you are initializing an object, you need to first call init on its parent class. This ensures that objects are created correctly through their hierarchy. The if statement, if, open parentheses, exclamation mark, self, close parentheses, introduces another concept that is prevalent throughout Objective-C. It returns nil or 0 if a variable does not point to anything. Another approach used to instantiate objects is to use a factory method. These methods are static methods. A static method does not need an instance of the class to call it. It also does not have access to any of the member variables of a class. In Objective-C, factory methods are more of a convenience method and are often used in many basic data structures of Objective-C. In the displayed code, the init method is defined in the NSObject class. Also, member variables of a new instance are set before returning it. In Objective-C, a static method is declared by using the plus symbol. The plus symbol defines the method as an instance method. Before we wrap up, see if you can answer this question based on what you've learned so far. If you thought option C was the correct answer, you are right. While there are no namespaces in Objective-C, methods are public and visible to other classes. Most classes inherit from NSObject in Objective-C, and signatures in Objective-C tend to be long and explicit. Here is a recap of the key points covered in this session.